Okay, so this is the parallel circuit that we worked on. We had two 10 kilo ohm resistors which are parallel with each other, and that's in series with 2 kilo ohm resistor. R1 is a 2 kilo ohm resistor, R2 and R3 are the two 10 kilo ohm resistors. And so we worked on that circuit. Now I have it hooked up with the actual circuit, and with well, I have about 11 volts. I'm supposed to have 12 volts, 11.6, that's pretty close. Okay, and then I drew the schematic out so that I'll have it in front of me, which is the standard that you should be following also. And then here's the actual circuit. Okay, so in this circuit, this is the first resistor, R1, this one, and this is R2 and R3. These are the two resistors which are in parallel with each other, and this is the series resistor. So this meter here, just looking at it, you can see it's the power supply coming in here, and it's coming out, so that must be measuring the current going into the circuit. Okay. And this one here and this wire here indicates that it's in parallel with this resistor, which is going to show the voltage across R2 and R3. And this one here, just looking at it, you can see it's in parallel, this wire and this wire together. So that's the voltage across this resistor here, which is R1. And looking at the numbers, you will see on the meters. So this meter right here is showing the current into the circuit, which is about 1.6 milliamps. Okay. And this meter is showing the voltage across R1, which is about 3.4 volts. And the third meter is showing 8.1 volts, and that's the R2 and R3. Okay, so R2, which is equal to R3 because it's a parallel circuit, that's reading 8.1 volts, and this one, R1, that's the first series resistor, and that's reading 3.4 volts, and the green color meter is reading the circuit current, which is about 1.6 milliamps. And those numbers are pretty close to what the actual numbers are. So let me see if I can move the meter up here to the circuit itself and the schematic. So this voltage here is supposed to be 8.5 volts, right? And this is the voltage that I'm reading, 8.1. Okay, so that's the voltage across R2 and R3. And the voltage across R1, which is the first resistor, it was supposed to be 3.4. You can see that it's 3.48 volts. Okay. And the current into the circuit, we said it's 1.7 milliamps. So that's the current going into that circuit, 1.6 milliamps. Now if I want to know what is the current going into one of the resistors, so we know what this current is, it's 1.7, we just showed that, but we don't know that this one, this current here, by the way, that's supposed to be a 0, that's 0.8 milliamps and 0.8 milliamps. We don't know that, and if I want to measure that, all I have to do is to break the circuit So just pause the video here, and you tell me how you would measure the current going into, let's say, this resistor here. So what you would want to do is to break this circuit right here. Instead of the current going in like this, you want that current to this resistor be broken. And how you would do that is just move the resistor over one place. So I'll just move it over. Just make sure that when you do that, move it like that. I'm going to put this lead here, and I want to come back into the circuit here. So that will bring the current into that circuit. So it comes out. I missed one of the spots here. I missed right there. And that shows 0.78 milliamps. Okay. So that's the current going into this top resistor here, this resistor right here. Now let's say like in the examples we worked out, remember we put some short circuits and opens. So let's try a few of those also while we got this thing set up. So let's say I want to put a short circuit across R3. Okay, so all I have to do is just put a wire across that resistor, and now I have a short circuit across that. So when I do that, the voltage across that section becomes 0 volts. Okay. So that's R2, and voltage across R2 and R3, that becomes 0 volts. It's because I have a short circuit there. And also now the total current would go up because it's just one resistor, which is the 2 kilo ohm resistor. So the current into the circuit, instead of it being 1.7 milliamps, has become 5.3 milliamps. That's because R2, R3 is shorted out. So R2 and R3 do not even exist in the circuit any longer. So the current, instead of it being 1.7 milliamps, which is what we calculated, the current now is 5.3 milliamps. Which makes sense. If you divide voltage, the 12 volts by 2, you get about 6. I get 6. 5.3, pretty close. Okay. So that's if I put a short circuit across R3. So let's try one more. Let's put a short circuit across R1. So if I do that, then so that's R1. So when I do that, the voltage across R1 becomes 0 because it's a short circuit. Okay. And now the current in the circuit, remember, so if I short circuit R1, so if I short circuit this resistor, the only resistance in the circuit is these two resistors. So the total resistance of these two is, because they're 10 kilo ohms, the total resistance would be 5 kilo ohms. So it will be about 1.4 milliamps or so, the total resistance. I'm sorry, not 1. It's 12 volts divided by 5, so it's 2.3 or so. And that's what I get. So I get 2.2 milliamps into the circuit. So initially I had 1.7, and because I shorted out R1, now the current has gone up. Okay. So that's when I short out R1. Okay. And the other thing that we did was have an open on R1. So pause the video. So pause the video and you tell me what that should be. Okay. Right. So here's where I'm going to open the circuit. Just take this resistor out. You just take it out, and you'll notice that the current in the circuit dropped to 0. Okay. The voltage across R1 is source voltage, 12 volts. Okay. And there's no voltage dropped across R2 and R3 because there's no current going through that circuit. Okay. That's when I open R1. So we put that back in to the circuit. So I think it should be working fine. All of the numbers are right. The other one is, let's say I have an open on R3. So to do that, I'll just take that out. Okay. So now I have an open there. So the total resistance is so if there's no connection here, if this resistor disappears, okay, that's open, then the total resistance is this resistor and this resistor. It's a simple series circuit. So that's a 12 kilo ohm circuit, so I should be getting something close to 1 milliamp going through the circuit. This is what I get. Okay. 9.3 milliamps, 1 milliamp, pretty close. So that's open on R3. And because it's 1 milliamp, the voltage has gone up across R1 to 2 volts. That makes sense, right? So it's 2 kilo ohms times 1 milliamp, 2 volts. And the voltage across R2 and R3 has jumped to 9.5 volts. That also makes sense if you look at the two voltages. The 2.1 plus 9.5, that's pretty close to 11 volts, right? 11.5 volts, which is our source voltage. So that's the open on R3. So we've done the short circuit on the parallel circuit. We've done the short circuit on the series circuit, we did the open on the series circuit, and we did the open on the parallel circuit. And this is also remember, this is a compound circuit, it's not a simple series or parallel circuit. Right, we should be having a pretty good idea what series and parallel circuits are.